Okay, well, I'm sorry for being a couple minutes late here. Every conceivable thing went wrong getting down here from my office. So welcome to week 5. What we're going to take a look at in this lecture is regular expression notations, which allow you to search for and also do substitutions of patterns in text. We're going to take a look at some tools for reading and writing formatted data from the web or from files on the disk. And if we have time, we're going to take a quick look at some methods that you can use for manipulating string objects. Any questions about anything before I launch into this? Okay. So a regular expression is like a sort of mathematical notation for very precisely and compactly describing a pattern of text. Originally, this was developed for dealing with parsing of human languages, but computer scientists, I think actually before the term computer scientist was invented, people that were interested in computer programming languages and compilers grabbed this idea of regular expressions to describe programming languages and parsers for programming languages. So the Unix operating system popularized regular expressions at the ordinary user level with a command called grep that you could use to search in text files for patterns. And since then, all kinds of user environments and languages and word processors and so forth have made use of regular expressions. Python has an extensive collection of special characters that you can use to represent regular expression patterns, and several functions that you can use to search for them or replace them or what have you. Here, and now I realize I really need side-by-side screens, but we'll do our best. Actually, you know what? I'm going to pause for just a moment and set things up so I can kind of flip back and forth between pages a little bit here. Okay. All right, so now I can leave this table of regular expression characters on one screen, and we can walk through a sequence of examples on a well, it's all the same screen, but different views of this screen. So in regular expressions, most characters just match themselves. So if you search for little a, you're going to find, or not find, little a. And if you search for the symbol 7, you're going to find or not find a 7. But the rest of the characters shown on this page have special meaning in regular expression notation. For example, the caret symbol, which is known by a lot of different names. I like to call it the caret because that's nice and short. It's also called the circumflex, or the up arrow, or the hat, or a whole bunch of other things. That symbol matches the beginning of a string. So, in other words, when I use the caret symbol in a regular expression pattern, what I'm saying is, I want to search for something at the beginning of a string. And as an example, if I search for this pattern capital H, what I'm doing is I'm searching for lines in my document that I'm scanning for lines that start with a capital H, line where the very first character on the line is a capital H. Now, to show these regular expression characters in this list here, I'm going to use a silly little poem as an example. It has the advantage of being short and a little bit funny, so it's a little bit easy to remember, and it's English, which makes it, again, easier to talk about than if it were, you know, some kind of comma-separated value file with all kinds of floating point numbers in it. So this is a poem by Lewis Carroll from Alice in Wonderland called How Doth the Little Crocodile. And you'll notice that it's got about 14 lines in it altogether, including the blank lines. Some of the lines are indented. Most of the lines start with capital letters. One starts with a lowercase letter. So there's a lot of material in here that we can use for just experimenting with regular expression searching. All right, so I have that poem in the regex examples program that is posted on Canvas, and this poem is represented as a list of strings. Okay, so the first line in the poem is the first string, the second line in the poem is the second string, etc. And what I'm going to do here is to, first of all, import the regular expression module so that I can use regular expressions. And the regular expression module's name is so short that nobody uses an abbreviation for it, basically. I'm establishing the pattern that I want to search for, which is lines that start with a capital H character. And then, for each line in this poem, that is, for each string contained within this poem, I am searching for my pattern, that is, I'm searching for capital H in each line, that is, in each string. Now, if the pattern does not exist in the line, then the regular expression search function returns none, meaning that there was no match. So I only want to display some output here if the value I get back from the search is not none. All right, and in my case, all I'm doing here is if the value from the search is not none, that means that the pattern was found, and I'm just going to print out the line that matches the pattern. All right, so that was a lot of talking. Let me just run this, and we should get out lines from the poem that start with a capital H. F5. F5. There we go. Okay, so in the poem, there are exactly 3 lines that start with a capital H character. Okay, if we look back at the file, all right, so we've got the title line, we've got the first line of the first stanza, and we've got the first line of the second stanza. Now, there are other lines in this poem where the first letter on the line is a capital H. Like here we have how neatly spreads his claws, but that line is indented. There are 2 spaces in front of that line, so that is not a match. In order to be a match, the very first character in the string has to be a capital H. So far, so good? Okay, so that's what the caret is about. If you say caret followed by some character, that's going to search for strings that exactly start with that character. Okay. Now the next thing we're going to look for the next bit of mess I have to warn you about is backslashes. You'll notice that the backslash is shown here as one of the regular expression characters. What the backslash is used for is to turn off the special meaning of the character immediately following the backslash. So let's suppose that I wanted to look for a caret symbol. Well, to look for a caret symbol, I would need to say backslash caret to say, all right, I'm not treating the caret as matching the beginning of the line now. I want to actually look for a caret symbol in my document. But I have a problem, which is that the backslash is already used in a special way by the string data type itself. All right, for example, we know that I use a backslash in front of a T to represent a horizontal tab. I use a backslash in front of an N to represent a new line character. If I want to get a literal backslash in my string, I have to say backslash backslash. Here's a quote. I can use a backslash in front of a quote mark to cause the quote mark to be treated as an ordinary character within the string. So the string data type itself uses backslash to represent horizontal tabs, new lines, literal backslashes, quote marks. And now the regular expression notation is also trying to use backslash for its own purpose. Okay, so here we have the horizontal tab. This is a new line test, a backslash here, apostrophe S. If I do, okay, let me say S gets all of this stuff. So now I have a variable S referring to this string that has backslashes in it. And if I say re.search for a backslash in S, well, this seems kind of reasonable, doesn't it? I want to search for a literal backslash in the string S. And according to the regular expression notation, if I use a backslash, that will turn off the special meaning of the character after it. So the first backslash is turning off the special meaning of the second backslash. That sounds good. It ought to look for a backslash in S. Seem fair? Sure, what the heck. Ah! I get this error message. Bad escape at position 0. What the heck does it mean? Well, the problem is that I have typed 2 backslashes to represent 1 backslash, but in regular expression, okay, let me back up. I have typed 2 backslashes to try to represent 1 backslash. But in regular expression notation, 1 backslash means that it turns off the special meaning of whatever the next character is. Here, there's no next character. So I've got a backslash followed by nothing. And consequently, to make both the string data type happy and the regular expression notation happy, I have to do this. I have to say search for backslash 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 in S. Okay, so first I need to look at this thing as a string. As a string, this is a backslash followed by a backslash, so that's 1 backslash. Then I have another backslash followed by a backslash, so that's another backslash. So now my regular expression consists of a backslash followed by a backslash, which is a literal backslash, and yay, I get told there is a backslash in S starting at position 15. Let's see whether that's true. All right, here's S. Now, a tab is just one character, so the tab is position sub 0, and then sub 1, 2, 3, 4, 5, 6, 7. New line is one character, so that's 8, 9, 10, 11, 12, 13, 14. Yay, I have a literal backslash at position sub 15 in my string. S sub 15 is a backslash. So did everybody understand all of that perfectly? I'm thinking probably not. So if you didn't entirely follow that discussion there, basically I'm just trying to warn you that backslashes in regular expression patterns are a mess to deal with. And so what we're going to do is to put an R in front of every string that we create that represents a regular expression pattern. R means raw, and R has the effect of causing backslashes in the string to just be treated as individual backslashes. Let me show you what I mean by that. Here's my shell. If I say S2 gets backslash T backslash new line backslash, how many characters are there in that string? 3, right? There's a tab, a new line, and a backslash. And if I ask for the length of S2, I get told there are 3. But if I say S3 gets raw string backslash T backslash N backslash, that string has 6 characters in it. It has a backslash, a T, a backslash, an N, a backslash, and another backslash. Okay, so henceforth, whenever we write a regular expression pattern, we're going to write them as raw strings so that we don't have to remember every time we want to use a regular expression backslash for some purpose, we don't have to remember that we have to double it. Okay, if I say pattern gets raw backslash caret, that would be an appropriate pattern that looks for a literal caret symbol in my poem. Now my poem doesn't have any caret symbols in it, but let me create a string that does. If I say S4 gets, this is a string with 2 caret symbols, and I say re.search for R for raw backslash caret in S4, I get told, yes, there is a literal caret symbol at position 8. Let's see if that's right. So here's position 0, 1, 2, 3, 4, 5, 6, 7. Yes, this is position 8 in the string S4. Okay. All right. So there's my table of basic regular expression characters. We've talked about how most characters just match themselves, like letters and digits just match themselves. Caret, as a regular expression character, matches the beginning of the string. And if you want to turn off the special meaning of a regular expression character, you put a backslash in front of that. In order to not have to remember to double your backslashes all the time, use R in front of your pattern. And that will save you a lot of headache. Okay. All right, so that was a that was a nasty little tar pit that we had to run down. Let's now look at some other examples. Okay, the next pattern that we're going to try is $. Now, caret, as the first character in the pattern, means to match the beginning of the string. And $, as the last character in the pattern, means to match the end of the string. So if we say, do a search for $, what does that mean there's allowed to be in the string between the beginning and the end of the string? Nothing. So the only lines that we should match, the only strings that we should match from our poem, are the lines that are empty, the lines where the beginning and the end are right next to each other. And if we take a look at our poem, it does have a few empty lines. The blank lines are represented as empty strings. So when I check for that pattern, I should get 3 empty lines displayed as output. So I'm going to say pattern gets R, quote, $. All right, and this is searching for empty lines. When I run it, that is what I get. I get 3 empty lines displayed as the output there. All right, so we've looked at caret for start of string, $, for end of string. Next up, we're going to look at using square brackets to specify that you want to match one character within the set or range of characters found in the brackets. Okay, so if I say square bracket, A dash Z, close bracket, what that means is that at that position I want to match, or I'm looking for, some capital letter. A dash Z in the ASCII character set, which we're using on our machines, are sequential in, as represented as characters in the system. So capital A is immediately followed by capital B, is immediately followed by capital C, up through capital Z. And so those are in a natural sequence, and I can use the hyphen there to indicate that I want to look for characters in that sequence. In the good old days, back in the 60s and early 70s, there were popular computers around that did not use the ASCII character set, which had the exciting property that the capital letters had a gap in the middle that had a bunch of punctuation characters. So on that kind of computer, if you said you wanted to search for something between capital A and capital Z, it would imply not only the capital letters, but also whatever these miscellaneous punctuation characters were. Unfortunately for us, on an ASCII machine, those are in sequence. Now, in front of the square brackets here, what I have are 2 space characters, which Adobe won't allow me to highlight, but so what I'm looking for here is lines that begin with 2 spaces and then a capital letter. All right, let's try that pattern out. So lines that begin with space, space, and then a capital letter between A and Z, capital A and capital Z. And there we go. So I have 4 lines in my poem, the 4 indented lines in the poem, that begin with space, space, followed by a capital letter. And I did not get any of the lines where the very first character in the line was a capital letter. I only got the ones where there were exactly 2 spaces between the beginning of the line and the capital letter. Make sense? Okay, next up we're going to introduce the star symbol. Now star, in regular expression notation, the star does not stand by itself. What the star does is to mean, let me say this a different way. What the star does is to modify the meaning of the character right in front of the star. And what it means is to match any sequence of 0 or more occurrences of whatever that character in front of the star is. So in my particular example, in front of the star here is a space. Okay, this pattern is a caret, and then space star, and then the square brackets, capital A dash capital Z. So I never want to look at the star as though it were standing by itself. I always want to look at the star and whatever is in front of the star. So space star means any sequence of spaces, including 0. Okay, star always means 0 or more. So what I'm looking for is 0 spaces, or 1 space, or 2 spaces, or 3 spaces, or 5 spaces, or 9 spaces, or 1,000 spaces. And between the beginning of the line and a capital letter, I'm saying all that's allowed to be there is some sequence, including 0, of space characters. All right, so if I run that pattern, all right, so instead of looking for lines that start with space capital letter, I'm now going to look for lines that start with space star, that is any number of spaces followed by a capital letter, and I will get all the lines where the first letter on the line is a capital letter, regardless of whether they are, right up against the left edge or indented with spaces. If I had a line that was indented with a tab, that would not be a match, because although a tab is considered to be white space, a tab is not the same thing as a space character. Question?
Yeah, so if you wanted 1 space or more, do you do space star?
Precisely. If I said, okay, so space star, you look at that as a unit, space star. Space star means 0 or more spaces. If I want 1 or more spaces, I would need to say space star. Okay, so space is going to match a space, and then space star is going to match 0 or more additional spaces. And let me do that. Let's look for space star. That will match all of the lines that have at least 1 space, perhaps more spaces, and then a capital letter. And in this particular poem, we just get the indented lines. Every line that we match actually has 2 spaces, and then the capital letter. Any other questions so far? Yes?
So what if I want to check 1 or more, or 0 or more for more than just a space? Let's say I have a tab space or a space, and I want to check any sequence of that. 0 or more in any sequence.
Okay, good. So the square brackets here allows me to look for one of the characters contained within the brackets. If I wanted to look for a space or a tab, what I would do is, in front of the star, I would use square brackets, and I would have space, tab. Okay, so space tab in brackets, star, means to look for a sequence of 0 or more spaces or tabs.
So if there is a tab, 3 spaces, and then my line starts, it will show up for.
Yeah, let me do that. Let me create such a line. So I'm going to change this one on every golden scale. I'm going to change those 2 spaces to a tab. Whoops. And I'll use the \t notation to insert my tab. So there I have a line that starts with a tab. rather than with two spaces. If I search for what I originally had here, which was space star, well, a tab is not a space, so space star A through Z is not going to match that pattern. I get lines that are indented by 0 or more spaces, but I don't get the line that's indented with a tab. If I now look for lines that have 0 or more tabs, well, actually, no, that's... Okay, that's going to backfire on me. One of the problems with the star is because it means 0 or more. Every single line in this poem begins with 0 tabs, correct? So if I look for tab star, it means just give me the lines that start with, give me the lines where the first letter on the line is a capital letter. So I actually want to look for,
Isn't that going to just look for a T? Because we switch off.
no, in the, oh, yeah, I see what you're saying. So here I would have to actually enter a tab character. And I'm not sure that, yeah, idle won't let me do that. All right, so I'm going to get rid of my R. Yeah, this will work. If I get rid of the R, then in the string, this is a literal tab. And so I'm going to find lines that start with a sequence of 0 or more literal tabs. Let me get rid of the star. Let me look for lines that start with a literal tab followed by a capital letter. And I only have one. So I only have one line that starts with a literal tab and a capital letter. If I said \t star, that would look for 0 or more tabs, and because every line that has a, because every line where the first character on the line is a capital letter, I can think of as having 0 tabs in front of it. I'm going to get this line, how doth the little crocodile. I'm going to get this line, and pour the waters of the Nile. I'm going to get this line and this line. I will also get the line that has a tab before the capital letter. So I claim I'm going to get, well, 6 lines of output actually. I'm also going to get the title. So I claim I'm going to get 6 lines of output if I look for a tab, if I look for a tab star. And there we go. Okay. It's you know, this is non-trivial, but it's also exceedingly powerful when you do get used to using it. You know, a pretty significant part of my data massaging, data manipulation parts of my career have consisted of using regular expressions to extract the subsets of data that I want and to get rid of the parts of the data that I don't want. It's really extremely powerful. All right. So we've taken a look at the star now. This next example is really easy. If I use E in front of $, that means to look for lines that end with an E. So let's try that one. I'm going to get rid of my caret, and I'm going to just say $E. So this will find and display all of the lines in the poem that end with a little e. So I ought to see the title, the first and third lines of the first stanza, and that's it. Now I do have a line here that ends with an E followed by punctuation, but that one's not going to match. So I should get 3 lines of output. Yep. So there are all the lines that end with a little E. Okay, in this next example, I'm using 2 sets of square brackets, and instead of specifying a range of characters, like from capital A to capital Z, I'm specifying a collection of individual characters that I'm interested in matching. So what I'm interested in matching now is lines that contain a lowercase vowel, A or E or I or O or U, and after that needs to be another lowercase vowel, A or E or I or O or U. Now, they don't have to be the same lowercase vowel. There just has to be a lowercase vowel followed by another lowercase vowel. And let's see what we get from that. Okay, so each one of these 4 lines that we found, okay, the first line has AI in it. So that's a lowercase vowel followed by another one. The next one has OU. The third one has EE. And the fourth one has EA. So each of these 4 lines does contain a lowercase vowel immediately followed by another lowercase vowel. Make sense? Okay, now dot means to match any one character. And let me, before we look at this example on slide 7, let me do a really simple example of dot. Let's see. So I do have my poem here. If I ask to see the poem, all right, there it is. So the poem is a list of strings, and if I say re.search for lines that contain t.e, well, I need to loop through 4s in poem. If re.search for t.e in s is not none, let's print s. Alright, so I'm looking for t.e. Now the dot stands for any character. So what I'm going to search for in the poem here is lines that contain a little t followed by a character, no matter what that character is, immediately followed by a little e. So t something e. And okay, now you look at this first line and you might get confused into thinking, wait a minute here, I've got a capital T followed by an H and an E, but that's not the match. Do you see where the match is? Yeah, the match is right here. TLE. Okay, so TLE matches T followed by a character followed by E. Then in the next one, we are matching THE. And in the third one, we're also matching THE. And the fourth one, we're matching TLE. Okay, so you can use a dot to match any one character. If I use multiple dots, that allows me to match some fixed number of multiple characters. So if I say T, well, let's do this. Let's do QRSTUV, one of those characters, followed by 2 characters followed by E. Okay, so this is going to search for strings that have either a Q or an R. Well, that's stupid. I can do a range, right? Either a Q or an R or S or T or U or V, one of those 5 characters, followed by 2 of anything, followed by E. I don't know whether we're going to get any results here. We do. Okay, so two characters. Okay, here we go. T followed by two characters followed by E. And the same thing here. Now, where's my... Okay, here we have R. R is in the range between Q and V, so we have R followed by two characters followed by E. And S followed by two characters followed by E. So in each case, we do have a match. We found one of the characters between Q and V, followed by two characters, followed by an E. Make sense? All right, so each dot that you use specifies a character. Now, in combination with star, remember that star modifies the meaning of the regular expression immediately in front of it. So the pair of characters dot star is how we match any amount of any characters. Okay, dot means to match any one character. Dot star means to match 0 or more of anything. So dot star is how we indicate, well, we don't care what's in there. We don't care how many characters are in there. We don't care what those characters are. But what we're looking for with this pattern is lines that contain an A, a little a, followed by anything, no matter how many characters, followed by a little e, followed by anything, followed by little I. So in other words, we're looking for lines that contain little a, eventually followed by little e, eventually followed by little I. And we don't care what's in between the A and the E, and we don't care what's in between the E and the I. So let me edit our program here to type that guy in. All right, so we're looking for A, dot star means anything, E, dot star means anything, I. Run that. And here we go. So we got two matches. Let's see if they make sense. So here's an A. Now eventually following the A there's an E, and eventually following the E there's an I. Right? So we do have A, E, I in order with some other characters in between. And likewise here we have A, E, I with some characters in between.
What if we don't use the star?
Okay, what if we don't use the star? Good question. What if I just said this? That's what you're asking? Dot means one character. So what this pattern says is to look for A, followed by a character, followed by an E, followed by a character, followed by an I. And that might match something. Let's see what we get. Okay, that didn't match any characters in the poem. But if I said, let's say A-E-S, that means A, character, E, character, S, and I know that's going to match at least one. There we go. Because here we have A, followed by character, followed by E, followed by character, followed by S. Okay?
So that means there could be only one character between two.
If you say dot, then you're saying there has to be exactly one character between these two characters. But if you say dot star, what you're saying is there could be 0 or more characters between the two characters. Now, let's try something like this. E dot star, E dot star, E dot star, E. What's that looking for? Well, that's looking for a line that contains at least 4 E's on it. And there may or may not be characters in between the little E's. Okay. Let's see. So, E, 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 E. All right, so that first line does contain 4 little E's. And the second line contains 1, 2, 3, 4 little e's. Now this third line contains 2 e's right next to each other. So in that case, the dot star is matching no characters. And then later on we have another e, and then later on we have another e. In fact, we have 2 more e's, but we only need to match 4. Okay, so dot star does match 0 characters, which is why the EE in cheerfully is a match to E dot star E. Okay, so we've covered a lot of ground now. We've looked at dot, which means to match any one character. We've looked at star, which means to match any sequence of characters, any sequence of whatever the character, the regular expression character in front of the star is. We've seen that you can use square brackets with just a collection of values like A, E, I, O, U, or you can use square brackets with a range of values like capital A dash capital Z. Now, instead of using a range, you could type out all the values. You could type capital A, capital B, capital C, capital D, capital E, capital F. You know, you could type all 26 letters out, and it would mean the same thing as the range, but obviously the range is a lot less typing. So the last sort of oddball in this collection of basic regular expression characters is the caret again, but this time inside of square brackets. So this caret, just to be as confusing as possible, has nothing to do with the previous caret that meant the beginning of the line. This caret, if it appears inside square brackets, means to match a character that is not one of the characters in the set. So if I... Where's my program? Okay. Okay, so this notation, square bracket, caret little t, close bracket, means that I'm looking for a character except for a little t. So I'm willing to match any character, whether it's a space or a punctuation mark or a digit or a letter. It can be any character at all except for a little t. It can't be a little t, but it can be anything else. Now, I also am interested in matching 0 or more things that aren't little t. And I require that there not be any little t's, that there only be characters except for little t's, all the way from the beginning of the line up to the end of the line. So that wacky looking notation says to match the strings where there's no little t anywhere in the string. Okay? The only characters that are allowed to exist in the string, all the way from the beginning up to the end, are things that are not little t. And let's try that one out. So, from the beginning, whoops, I need my R here just to be safe. From the beginning, I'm allowed to allowed to have characters that aren't t's. I can have 0 or more characters that aren't t's, and that has to be true all the way up to the end of the string. And there we are. So I do have, 6 lines that don't contain any little t's. This dashed line, which is the line underneath the title, obviously doesn't have any little t's in it. The line with the author's name doesn't have any little t's in it. As far as actual lines in the poem, the only one that doesn't have any little t's is the one on every golden scale. And then I also have 3 empty lines the empty lines don't contain any little t's. So those are the 6 lines from this poem that match. Every other line in this poem must have at least one little t somewhere. And yeah, so we've got doth, whoop, come here. All right, so we've got a T there, we've got a T there, we've got a T here, T here. So most of the lines in this poem do contain at least one little T, and therefore didn't match that pattern. Yes? Yes. Yes. So I can say, let's see, okay, well this is my program. Let me come down here and say, I want to look for lines that don't contain any character between P and S. So if the line contains a character P, Q, R, or S, then I don't want to match that line. So let's see if we get anything from that. Okay. Well, of course, S is a very popular character in English. So the only lines that didn't contain a P or a Q or an R or an S were the dashed line under the title and the 3 empty lines. Let me try to pick some more obscure characters. So let's find lines that don't contain, oh, this is easy, W through Z. Okay, so I want to get the lines that don't contain a W, X, Y, or Z. There should be some matches now. Well, fewer than I thought, but here we have a line that does not contain a W, X, Y, or Z. Actually, a lot of these lines, I just realized, do contain Y's in them. So we've got gently and neatly and cheerfully, and we've got welcomes. Other questions? Yes.
So, I'm more used to seeing the exclamation point as a indicator for not. So, is there any special meaning to an exclamation point when it comes to regular expressions, or it's just treated like any other character?
It's just another character. Yeah. Yeah, you're right. I mean, in a lot of C language-based languages, the exclamation mark is used for not. But for whatever reason, in regular expression notation, if the caret is the very first character inside of the square brackets, it means not. Now, just as an aside, maybe, right after the square bracket is the only place where the caret has that special meaning. If I put the square bracket over here, now what I'm saying is look for lines that can, well, what I'm saying is look for lines that begin with a sequence of W's, X's, Y's, Z's, or carets all the way up to the end of the line. So in this context, the caret is just treated as a literal character. And the same thing is true if I put my hyphen either at the beginning or end of the square brackets. This pattern that I've got here means search for lines that begin with a W or a Z or a caret or a hyphen, and in fact only W's, Z's, carets, and hyphens are allowed all the way up to the end of the line. Okay, so this notation is, it's very precise, it's very terse. It does take a lot of practice to to develop comfort with the meanings and placements of the various special characters. Any other questions so far? Yes?
Is there a way to return the match part?
Is there a way to return the matching part?
Yeah.
Actually, yes. When I say, okay, here's my poem, and let me just use the first line here. So poem sub 0 is the first string in the poem, and if I say re.search for, well, let's do something really easy, TT in poem sub 0. What I get back is something called a match object, and part of what's in this match object tells me the location of the TT. It tells me that the TT starts at position 15 and goes up to but not including position 17. Okay, so I'm not going to count, but you know, the H is position 0, and I'm willing to believe that the match is positions 15 and 16. Okay, other questions? Yes? Ah, excellent question. That's quite advanced. So here's my poem, and let's suppose that I want to find lines in this poem that have exactly 3 little e's. All right, well, I know that if I say re.search e.star e.star e, I guess I'm going to have to do this in a loop. So let me copy and paste my loop. Well, no, I'm being silly. Let's just do this in the program. So my pattern is going to be e.star e.star e. Okay, so that pattern says look for lines in the poem that have little e at least 3 times. And here we have all the lines that have little e at least 3 times. So we've got E, E, E. And then down here we've got E, 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 E. So we've got 5 E's. And now your question is, how can we find the lines that only contain exactly 3 E's? Ah, it's my favorite question. It really is. All right. How do I find lines that contain exactly 3 E's and all the other characters on the line are not little e?
Not e's appended to it.
I'm sorry?
Not e, the caret, not e.
Good. All right. Yeah, exactly. So we're going to say not E.
Okay, e dot star, and then
Okay, so E dot star, E dot star, E
dot, not e.
dot not E star.
It's just not empty when you want to replace every point with not E.
I want to replace what?
Every dot.
Every dot. Let's try this first. So this says find a little e, followed by anything, followed by a little e, followed by anything, followed by a little e, followed by a character and a character that's not e. So this is not going to do what we want, because I do still have this line in here that has 5 e's. Okay, because it has E, 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 And following that, I have a character that's not an E. I'm sorry. Following this E, I have a character that's any character, and I have a character that's not an E. So we'll try the... We want to replace all these dots with not E, correct? And get rid of this last part.
It's gonna end.
Okay, so this says find lines that contain a little e, followed by things that are not e, followed by little e, followed by things that are not e, followed by e, and I'm not done.
Then more naughty.
Should we just get all of it?
Let's try this. All right, so this says look for little e, followed by 0 or more things that aren't little e, followed by little e, followed by 0 or more things that aren't little e, followed by little e again. Oops. All right, so here I have a little e, followed by things that aren't little e, followed by little e, followed by things that aren't little e, followed by little e again.
But the next line there is for me.
Yeah, and the next line here is a little e followed by things that aren't e, because remember star includes 0. All right, so little e followed by 0 e's followed by little e is correct. And then here's a little e. All right, so that's on the right track, but I'm not restricted enough yet.
Not
Yes.
E start at the start and end.
I'm sorry?
If there's not E at the start and end of the
Good. Yeah, we need to start with things that aren't e's. And we also need to end with things that aren't e's. There, it's obvious. This is going to give me all of the lines that contain exactly 3 little e's. Because what it's saying is, let's look for lines that begin with things that aren't little e's, followed by 1 little e, followed by things that aren't little e, followed by a second little e, followed by things that aren't little e, followed by a third little e, and then things that aren't little e's all the way to the end of the line. Yay, we got it. So those are the the 2 lines, excuse me, that contain exactly 3 little e's. A lot of people think that you can't do counting with regular expressions, but you can. You just have to know how. Okay, very good. Any other questions so far? Cool, all right. Now, if I want to look for a period in a string, then because the dot means to match any one character, I need to put a backslash in front of the dot. Now, Lewis Carroll, who wrote this poem, was an excitable fellow, or at least his poems were excitable. And if we look at the poem, there's no periods in this anywhere. So if I search for a pattern of r, quote, backslash dot, I'm going to have no matches. No output at all. So let me reduce the excitement level of the poem a little bit and change these exclamation marks to periods. And then when I run it, I do get the 2 lines displayed that have literal period characters in the lines. Okay, so I mean, obviously that's something that's important to know how to do if you're trying to parse ordinary text, you know, human English language text or whatever. Obviously, you need to be able to search for literal periods at the ends of sentences. Okay, so that is the so-called basic regular expression characters with a variety of examples of how to use these things, not only themselves, but also in combination with each other to look for very precise patterns in your documents. Any more questions before we go on? Yeah? I'm sorry, you're too far away from me. You have to yell.
Yeah, I was saying that are these regular expressions particular to Python, or can we use them in other languages?
Okay, the reason that I called these things the basic regular expression characters is because these regular expression characters are found virtually everywhere. These will work in the Unix or Linux grep command. They will work in Python. They will work in regular expressions in the C++ language. These things are found virtually everywhere, including Python. Other questions? All right, so in addition to these basic regular expression characters, there are a lot more regular expressions, and Python does have a lot that are unique to Python. And I'm just not going to talk about those because usually those are just like shorthands for things that you can do using the ordinary regular expression symbols. So here are some more regular expression characters. These also work in almost all contexts where you can use regular expressions. They're not unique to Python. For example, the vertical bar symbol means or, and what this is going to match is either the string to the left of the vertical bar or the string to the right of the vertical bar. So I can, for example, I can search for how or Nile, and that will displace for me all of the lines from the poem that contain either how with a capital H or Nile with a capital N. And I think I get 5 or 6 lines from that. 5. Okay, so here we have lines that contain how with a capital H. There are 4 of those. And I also have one line that contains Nile with a capital N. Okay, so that's vertical bar. Now, you can use parentheses around an expression. What that does is to create what's called a regular expression group. And the purpose of creating a group is so that you can search for that same group again later by using a backslash followed by its group number. So if you create a group in your regular expression pattern, the first group is group number 1, and the second group is group number 2, and the third group is group number 3. And then you can indicate that you want to search for one of those groups again later in the same string by using \1 or \2 or \3. So let's see an example of this. Let's search, whoops, where's my, okay. Let's search for a line that contains a lowercase vowel, A, E, I, O, U. All right, so this is basically what I've done before. I'm using square brackets to say I want to search for a lowercase vowel. By putting parentheses around that, I have made that group number 1 in my pattern. And now I'm going to say, okay, I want to search for exactly that same character again. So whatever lowercase vowel I found, I want to search for that vowel back to back. So in other words, AA, I don't have any aardvarks in my poem, but if I did, that would match. EE, II, OO, UU. Okay? So let me see if I have any identical pairs of lowercase vowels. And I do. I only have one line. All right. We have EE right next to each other. Okay. If I had words in this poem like look or book or aardvark, then those would be matches as well, assuming that both of the lowercase vowels are lowercase.
If the number changes to 2, does that mean that there has to be triple character?
Let me catch up with that question. We're going to see an example of that shortly. So the parentheses create a group, and the backslash allows you to match whatever group the nth group. Let me show another example of creating a group, and then we'll get to the 3 different groups in the same pattern in just a minute. Okay, so in this example here, the third example on slide 9, what I'm looking for is any 3 characters followed by any characters at all, followed by that same pattern of 3 characters again. Okay, so this is going to display the lines from the poem that contain the same sequence of 3 characters at least twice, and there may be other characters in between. Okay, so ... means to match 3 characters. Could be any 3 characters. However, in order to match, that same sequence of 3 characters has to occur at least one more time. And let's see what we get now. All right, now these first 2 lines, you kind of scratch your head for a moment maybe, but actually these are really obvious because I have ... which is 3 characters, and then immediately I have the same 3 characters again. Likewise, the line containing the author, I have space, 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 and immediately I have space, space, space again. So both of those lines trivially contain 3 characters, eventually followed by the same 3 characters again. This next line down is a little tougher. Let's see. Oh, okay. I've got, here we go, space TH, followed later by space TH. Now remember that space does count as a character. So it is going to find space TH and then discover that space TH occurs again later. The fact that I've got THE followed by THE, or that I've got HE space followed by HE space, those don't matter because those are later examples than the first example that I find, which is space TH. But that line does have space TH in it 2 times. And the next one turns out to be here, ES space, ES space. Okay, so welcomes and fishes both end with the 3 characters ES space. Good? All right, now in this 4th example on slide 9, I'm creating 3 groups, but each group only has 1 character in it. So I'm looking for a character, followed by a character, followed by a character, and then I'm using dot star to indicate that there could be some separation. And then I'm saying, all right, I want to find those same 3 characters again, but in a different order. I want to find the 3rd character first, immediately followed by the 1st character, the 3rd character first, immediately followed by the 1st character, and then the 2nd character. All right, so I have character 1, character 2, character 3, followed by character 3, character 1, character 2. Let's see if we got any matches with that. Whoop. Okay. Okay, so here we have all the matches, and the first two lines, again, are kind of trivial. Here we have characters 1, 2, 3, followed by characters 3, 1, 2. And we have characters 1, 2, 3, followed by characters 3, 1, 2. Alright, so those are pretty easy. What about the next one here? Now, the first thing that you might notice in the third line of output here is that we've got a th space followed by a space th. That is, we've got characters 1, 2, 3, and then 3, 2, 1. But that's not actually a match because you can't use the space. You can't use the same space in the two different patterns. So there must be some other match going on here. Anybody spot it? This one's a little harder. Okay, so we're looking for characters 1, 2, 3, later followed by 3, 1, 2. Here we've got characters 1, 2, 3, E space L, followed later by 3, 1, 2, LE space. Okay? The next line's a little easier, actually. Here we've got 1, 2, 3, followed by 3, 1, 2. So his followed by shining is our match there. And what about this last one? Sorry? Ah, excellent. This is actually a tab. Remember, we put that backslash T in, so that's a tab, so that's not our match. Yeah, we've got N space E, so that's 1, 2, 3, and here we have 3, 1, 2, EN space. Now, why in the world would you care about this kind of mess? Well, let's suppose that you have some giant text document, and the data that you're particularly interested in is lines where you've got some people's names. You've got first name, middle name, last name. And then later on in the same line, you have last name, first name, middle name. And those lines, that pattern happens to identify the particular lines that you want to extract, I don't know, to get salary information or stock ownership information or something like that. So this is a very useful thing to know how to do, is how to search for lines that contain the same kinds of patterns but in different orders in different places. Okay? I can tell everyone is very convinced. This is great stuff. This is my favorite stuff that we've talked about so far. Okay, so we've got vertical bar, we've got groups. Now, we also have plus and question mark, which are kind of related to star. Remember that if I have a character followed by star, it means to match 0 or more of that character. If I have a character followed by plus, it means to match 1 or more of that character. So in the case of plus, there has to be at least one occurrence. Previously, somebody asked me how we could look for 1 or more spaces, and I said, well, what we would want is a pattern where we had space, space, star. That looks for a space followed by 0 or more spaces. But as a shorthand, I can say space plus. Space plus means 1 or more spaces. It's just an abbreviation for space, space, star. And then the question mark means either or. So if I say space question mark, that means there might be a space, there might not be a space. You know, there's either one space or there's not one space. why would that ever arise? Well, how would we match an integer value? Let's suppose that we ask the user to type some input, and we want to check that input to see whether that input represents a valid integer. What does a valid integer look like? Well, it starts with, now it could be positive or negative, so it starts with what? Sorry? Sorry, yell at me.
Plus or minus.
A sign. Yeah, so it starts with a plus or a minus, but it might not have a sign, right? So the plus or the minus is optional. Okay, so it starts with an optional plus or minus. There might be a sign, there might not be a sign. And then we have digits, 0 to 9, star, dollar. I'm sorry, 0 to 9 plus. We better have at least one, right? Dollar. Okay, so there's a pattern that looks for a correctly formatted integer as a sequence of characters in a string. There might be a sign, that's optional, and then there definitely has to be one digit, and there may be more digits to represent an integer. Okay, and so that's what we have. That basic idea is what we're showing here on slide 10, is that another way of using regular expressions is to validate patterns of input, either from a user or from some text file that you're trying to process. A Python integer has to start with, well, this actually, the one that we just did was better than this, because this doesn't account for the possible sign. Now, a Python identifier that you can use for a variable or a function or a class or a method has to start with a letter or an underscore, and after that you can have 0 or more letters, underscores, or digits. Notice that it's perfectly okay in square brackets to specify two different ranges, because in a Python identifier, the letters can be either uppercase or lowercase. So I can say little a through little z, which happen to be in sequence in ASCII, and big A through big Z, which also happen to be in sequence, to mean either a little letter or a big letter or an underscore. Okay, so that's a range of examples of what's going on with regular expressions, how to use them to recognize various patterns, how to search for patterns, how to recognize the validity of patterns, and so on. Any remaining questions at this point? When is he going to shut up, they're thinking. Well, I will shut up now, in fact. It's 7:30, so let's take a 10-minute break, and then we'll move on to the second part of this lecture.